Hello friends, this is video number 11 based on topic solutions. So in this video we are going to learn one more important aspect, that is the second colligative property, that is what? The boiling point elevation. So in the previous video we already studied the lowering of vapor pressure. So second colligative property is the boiling point elevation. Boiling point elevation, that is elevation means increase. Elevation means increase. So see at the beginning what is meant by boiling point. We know the boiling point of a liquid is nothing but the temperature at which the vapor pressure of liquid becomes equal to the atmospheric pressure. So that is what. So when liquid boils, the temperature at which vapor pressure of a liquid becomes exactly equal to the atmospheric pressure, or that is nothing but the applied pressure. So when a liquid is heated in a open container, so at that time whatever may be the temperature at which the vapor pressure of this liquid becomes equal to the applied pressure, means in open container now the applied pressure is the atmospheric pressure. So that's why what is that? A boiling point of a liquid is defined as the temperature at which vapor pressure of a liquid becomes exactly equal to the applied pressure. So means what? That is nothing but the atmospheric pressure. So see, so it is observed that, or it is found that the boiling point of a solvent or pure solvent increases when non-volatile, non-electrolyte solute is added in it in order to make a solution. So what is that? Try to understand. It is found that, it is observed that the boiling point of a pure solvent is increases or elevated when non-volatile, non-electrolyte solute is added in that solvent in order to make the solution. So this is called as boiling point elevation. This is called as boiling point elevation. So see, so that is what? The boiling point of a solution containing a non-volatile solute is increases compared to the pure solvent. So that is considered as the boiling point elevation. Okay, so if T0B or T0B represent the boiling point of a pure solvent and TB be the boiling point of solution, so then TB, that is boiling point of solution, is greater than that of the boiling point of pure solvent, and therefore see here, so this can be given like this: the difference between the boiling point of solution and the boiling point of pure solvent at the given constant pressure is called as boiling point elevation. See, so what is that? Delta TB. What is that? Boiling point elevation means what? It is also defined as, what is that? The difference between the boiling point of solution and the boiling point of solvent at the constant pressure is nothing but the boiling point elevation shown by delta TB. Okay, now see, boiling point elevation as a consequence of vapor pressure lowering. What it means? See, boiling point elevation is a consequence of vapor pressure lowering means what? That is what? The vapor pressure lowering is the another evidence which shows how the boiling point elevation occurs. So in the previous video we have already studied the vapor pressure lowering. We know the vapor pressure of solution is always found to be lower than that of the pure solvent, which is considered as the vapor pressure lowering. So this is again the one of the supporting or evident for what? That is the boiling point elevation. So how? So see here, we know in this case when the vapor pressure of solvent and solution is plotted against the temperature. So in this case it is observed that, now see, the solvent solution vapor pressure temperature curve for solvent and solution. So we will get the solution curve or curve for the solution or solution curve is lower than that of the solvent, because we know the vapor pressure of solution is always lower. So see here, so the curve AB indicates the vapor pressure of solvent and curve CD, that is vapor pressure temperature curve for the solution. So from diagram it is observed that vapor pressure temperature curve for solution is found to be lower than that of the solvent. So see, so here from graph, now see, it is observed that the curve CD intersects where, that is at 160 mm or at 1 atmosphere pressure. So this is at this point. So this intersect. So this is nothing but the boiling point of solution. This is nothing but the boiling point of solution, and AB curve intersects at this point. So this is to the what, that is 1 atmospheric pressure or 760 mm pressure. So this intersect this point is nothing but the boiling point of pure solvent. So in this case it is observed that, so on this axis temperature is there. So the difference between this, now see, TB minus T0B, that is delta TB. So this is the elevation in boiling point. From graph it is observed that delta TB, so that gives the elevation in boiling point. Our graph shows how the boiling point is elevated. So what is that? We know, so the lowering of vapor pressure is given by the expression X2 P10. Is it right? So boiling point elevation is depends upon this delta P. So as a result of that, delta P, that is the lowering of vapor pressure, again depends upon the mole fraction X2 and the vapor pressure of pure solvent, that is the product of these two. And similarly the elevation in boiling point is depends upon this lowering of vapor pressure. So see, the boiling point elevation and concentration of solute. So how the boiling point elevation is depends upon the concentration of solute. So you know, boiling point elevation, it is observed that, so it is directly proportional to the molality, that is the concentration of the solute in the form of molality, that is what, small m, molality. It is observed that elevation in boiling point is directly proportional to the concentration in what, that is molality of solute, and that's why this is shown like this mathematically. Delta Tb is directly proportional to small m. Paha hai ki elevation in boiling point, how directly proportional to the concentration of solute, that is expressed in terms of molality. Concentration, hey, molality मध्ये we know that is the number of moles per kg of solvent, that is the molality, and therefore we can write delta Tb is equal to Kb into m, where Kb is called as molar elevation constant, or that is the boiling point elevation constant, or this is also called as ebullioscopic constant, Kb. So if m is equal to 1, solution for 1 molar solution, so delta Tb, or in this way the ebullioscopic constant, this is also called as molar elevation constant, that is nothing but the elevation in boiling point for 1 molar solution. If m is equal to 1, we will get delta Tb is equal to Kb. What it indicates? That is elevation in boiling point for 1 molar solution, or in this case units of Kb are like this. Kb is equal to, हे असं लिहिता येईल आपल्याला, Kb is equal to delta Tb upon m. Delta Tb unit is Kelvin, molality moles per kg, so Kelvin into kg per mole is the elevation, that is the molar elevation constant, unit for molar elevation constant or ebullioscopic constant Kb. Okay, are you getting? So in this way we can understand what is the boiling point elevation. Okay, so in this way the boiling point elevation is explained with the help of the vapor pressure lowering, and again this is also the colligative property, as it depends upon the concentration of solute, number of solute particles. That's why boiling point elevation is also considered as the colligative property. So in the next video we will study how to determine the molar mass of a solute by using the boiling point elevation, and that is what finally the numericals based on this. Okay, so if you like, don't forget to subscribe. We stop here. So watch the complete video and try to understand this second colligative property. Thank you.